Okay, so for section 1.10 in our books, we're going to take a look in the podcast at just variation. And we have several different types of variation that we're going to look at. The first thing we're going to look at is direct variation. Okay, and there are two basic types of linear models. The more general model has a y-intercept that is non-zero, and we should be quite familiar with that one right now. So y is equal to mx plus b, where the b is not equal to 0. But if we simplify that, and if we just look at the model that has always a y-intercept of 0, then we no longer need that b value there. So it's just y is equal to some constant times x. Okay. In this simpler model, y is said to vary directly as x. So y varies directly as x. Or sometimes they'll say y is proportional to x or directly proportional. Okay, so that's just different words for the same thing. But that's an example of a direct variation. And in Pennsylvania, the state income tax is directly proportional to the gross income. So the state income tax, let's say, is y, and it varies directly as the gross income. So let's say that the gross income is x. Okay, so y is the state tax in Pennsylvania. X is the gross income. All right. Well, let's say that your income tax deduction is maybe $46.05 when you have a gross monthly income of $1,500. So we want to come up with a model for this that gives the state income tax in terms of gross income. So in place of the tax, so in our equation here, we're going to put 4605, and that's equal to some constant times the income. And our particular income in this instance is $1,500. So if we solve this for k, we find that k is equal to 0.0307. So the equation for state income tax in Pennsylvania then is y is equal to 0.037, or they're taking over a little of 3% of your gross income for the state tax. Okay, so there's an example of a direct variation model. Sometimes you can have direct variation as an nth power. So for example, if you remember from geometry, area varies directly as the radius squared. And I know that the formula for the area of a circle is area is equal to pi r squared. So if I know the radius, I can square it and multiply it by pi. So this pi never changes. It always remains constant. So that's what the k value stands for. What is that value that never changes in your direct variation? So like the income tax, they're not going to charge one person 3% and another person at that same income level a different tax. So it has to be a constant. All right. So in our case then, for the area of a circle, pi is our constant. But it's not just, it's not a linear model, so this one is a power to the nth. And that still works. That's still an example of a direct variation. Now, inverse, maybe I'll just go to a new page. Inverse is a little different than that. So we're going to look at an inverse variation. And instead of y varying directly, you might say y varies inversely as x. And in that case, y is equal to constant divided by x. So maybe they'll just say varies inversely, or sometimes they'll say inversely proportional. But we still have a constant in there, but we're dividing by the x instead of multiplying by the x. So if you see, if we redo this, the constant is equal to y times x. Okay. So an example of an inverse variation is, let's say that you ordered a pizza and your pizza has 12 slices in it. They've cut it up and we have 12. Whoops, I guess I spelled that. I got to spell that wrong. It has 12 slices of pizza in it. And if you eat the pizza all alone, you get 12 pieces. If you invite a friend, you each get 6. If you invite 2 friends and you each eat the same amount, you each get 4. And so the more people you invite, the less you get. So that's an example of an inverse variation. Okay. Sometimes, another example of an inverse variation is like on a seesaw or a teeter-totter. So you know that on a teeter-totter that a person that weighs heavier than someone else can still balance it, and that's because your weight and how far you are away from the fulcrum the product of those two has to be the same. And so your constant then is the product of the person's weight and how far they are away from the fulcrum. So that always has to be the same. So the heavier you are, the closer you have to set into the fulcrum. Closer in on that seesaw you have to set. Okay. You can also have joint variation. And a joint, let's go. And a joint variation is where you have more than one variable in a direct variation. So it's similar to direct, but if they say that z varies jointly as x and y, then you set it up like this. You say z is equal to some constant times x and then times y again. And you could have 2 or more in there, but a joint variation is pretty similar to a direct variation, just more than one variable. So once again, it could be read z varies jointly as, or sometimes they'll say jointly proportional. Okay. An example they have in the book for that is simple interest on a savings account is jointly proportional to the time and the principal. Okay, so if we wrote out that equation, simple interest varies jointly or is directly proportional to some number, you can't not have that number in there, some constant, times the principal and the time. So let me read that again. It says the simple interest for a certain savings account is jointly proportional to the time and the principal. So interest is jointly, varies directly, but with 2 of them, as the time and the principal. Okay, so you'd set up an equation like that. And then if they give you values then, or numbers to plug in, then you can solve it for the constant. See what that constant is for it. Okay, in their example, they have after 1 quarter the interest on the principal. So 1 quarter is 3 months. So after 3 months, The interest on a principal of $5,000. So you got $5,000 in the bank, and after 3 months, you made $43.75. Whoa, that's an ugly 5. $43.75. So you substitute it in, and you figure out what the constant is. Okay, so in our equation, the time in anytime you have banking problems like this, the time is always in years. So we got to convert the 3 months to a fraction of a year. So that's going to be 1/4 of a year. Okay, so the amount of interest was $43.75. So that's the I value. We're trying to figure out what the multiplier is here, what the constant is. The principal is 5,000. And the time is 1/4. Okay, so if you solve that, if you get out your calculator, you will find that the constant is equal to 0.035. So we put this value back up in for the constant, then in that equation. Okay, so the amount of interest is equal to 0.035 times principal times time. Alright, so when it says solve for the constant of variation, that's what you're looking for, and every variation has a constant, so you just have to solve for it. So that's a few examples. This one's kind of short. The rest of that, with the math modeling and stuff, and how you find lines and curves of best fit, that kind of stuff, we will just do in class because it involves using our calculators. So I will just leave you with kind of a short podcast for your notes. Hope you like that.